Hello friends, my name is Pooja Arora and we are having some video lectures on the subject of mathematics, and in my previous video we have already discussed some basics of matrices. That means the matrix definition, the order of the matrix, and we have the introduction of few various types of matrices. So in today's lecture what we are going to do some operations on that matrix. Okay, so very first operation which I am talking about is the basic operation, that is addition. So matrix addition is quite simple. It is quite similar as the normal number addition. In the same way you can add matrices, just only you have to add one condition. So whenever you are going to add two matrices, you have to firstly check the condition. Okay, and what is the condition here? The condition says that the order of two matrices should be same. That means if I am saying add matrix A and matrix B, then the order of matrix A and the order of matrix B should be same. Now if at this point if you don't know what is the order of the matrix, just go back to my previous video. In that we have discussed about the order of the matrix. Okay, let's understand this condition with an example. If I am having a matrix like 1 2 3 4 5 6 and I am having a matrix B like 1 2 3 4 5 and 6. So in my last video I have already discussed what is the order of the matrix. Here the matrix A has the order, I think you all can answer right now. So it is 2 by 3 because there are 2 rows and 3 columns in this matrix, so the order is 2 by 3. But here in the matrix B, if I mention the order is 3 by 2. Okay, so the first matrix has the order 2 by 3 and the second matrix has the order 3 by 2, then we cannot add these two type of matrices. The addition is not possible. If this type of question is given in your paper or in the book, you can clearly answer that the addition of matrices is not possible because the order is not same. So very firstly, whenever we are going to add two matrices, we have to check the order should be same condition. Okay, so what if I have a matrix like this, just like 5 9 1 7 2 0. Okay, so now I have a matrix A and I have a matrix B of the same order because matrix B is also having 2 rows and 3 columns. So now the order of two matrices are same. So that means condition satisfy and we can perform the addition. Till now we are clear that we can perform the addition. Now how can we perform the addition? For that what we have to do, we have to add the elements of same position. In the last video lecture, if you remember, I have already told you about the elements position, that is Aij. We denote a matrix like this. Okay, so what is this? This is the element of matrix A with the position Ij. Ij means row number and column number. So here what we are going to do, that if I am having two matrices like Bij, same order, so I am writing M cross N here. So what we are going to add? We are going to Aij and Bij. That means element at the same position. Just like this one is at position 1 1, first row and first column, and here at the first row and first column we are having 5. So what we are going to do? We are going to add this 1 and 5 in the addition. So what will be my resultant matrix? It will be 1 plus 5. Okay, and same way we are adding all the elements at the same position. Here we are having 2 first row, second column, so we are going to add 2 9, 2 plus 9, and then 3 plus 1, and I hope you understand the concept. Now you can add, that is 4 plus 7, 5 plus 2 and 6 plus 0. So that will be your answer of the addition of two matrices. Now you can clearly see the answer will be 6 11, that is 4, that is again 11, that is 7, and that is again 6. So the addition of matrix A and B will be this. So what we are going to do in addition, 2 points here to note. The first point is the condition, that very firstly you have to check the condition that order of two matrices should be same, then only we can perform the addition. Okay, and second point says that you have to add the element at the same position. Aij will be added to Bij, then you get the resultant matrix. I think concept of the addition is clear, and we can take one more example. Okay, so what if I tell you to add 1, 2, 3, 4, 5, 0, 1, 3, and my second matrix is -1, -5, 4, 0, 3, 6, 1 and 5 with minus. So here I am taking an example with some negative value. In mathematics you can always see some kind of negative values there. So there is no need to confusion. We can easily add these two matrices just because order is same. There are 4 into 2 and this is also 4 by 2 matrix. Because there are 4 rows and 2 columns, so we can easily add these two type of matrices. So very firstly what I am going to do, it is adding these two elements. So what I am adding, okay, for those students who are not from maths and who are not sure about the negative addition, just I am doing this, just like we are adding 1. What I have to do, I have to add what? I have to add -1. Okay, so if you write like this in the bracket format, then you will never get a wrong answer. So if you are not very not very sharp with negative numbers, I will suggest you to do this practice. If you do your calculation like this, you will always get the right answer. So what will I get here? I am multiplying these two sign, and okay, let me tell you about these one. If you multiply plus and plus, you will get a plus. If you multiply plus and minus, you will get a minus. If you multiply minus and plus, you will get again a minus. But if you multiply minus and minus, you will get a plus. So if you don't know these about the sign of multiplication, then you can note it down at the separate portion. It will help you throughout the maths in any calculation. Okay, so what here what I am doing, I am multiplying plus and minus. So it is here mentioned that it is a minus. So I got 1 minus 1, and we all know that 1 minus 1 is equal to 0. In the same way, we can add 5 plus minus 5. So what will I get? I think now you all can answer. This is also minus 5 minus 5. It is also 0. Okay, so I think now you got the point, and now you can add these two matrices and give me an answer here. So I am writing answer here. You can check your answer, and if you still don't get it, you can ask me. Just like 1 minus 1, here we are getting 0. 5 minus 5, that is also 0. 2 minus 4, that is minus 2. 0 minus 0, that is 0. 3 minus 3, that is 0. 1 minus 6, here I am getting minus 5. Okay, so 4 minus 1, that is 3, and 3 minus 5. You can check it like this. Again, if you are confused, so minus, what is minus? This is plus. So what I am getting? 3 plus 5, and 3 plus 5 is equal to 8. So this will be my final answer for matrix addition. I think now the matrix addition is completely clear, and if you have some doubt, you can still ask me in the comment section. But I think the concept of matrix addition is clear now. 2 points here I'm going to add. And what's that? We have some properties of addition. In the basic mathematics, you already know that addition is always commutative. So here also matrix addition is commutative. That means if I add A plus B and if I add B plus A, I will have a same answer. A plus B must be equal to B plus A. So this is called commutative law. In the same way, you can have associative law. So A plus B plus C is equal to A plus B plus C. So this associative law is also true for matrix addition. So these two laws of basic mathematics apply on the matrix addition also. You can note it down till now. Okay, so matrix addition is clear, and now we are moving to the next operation of matrix, that is subtraction. Okay, so we have understand the addition concept. Now we are going to understand the concept of subtraction. Addition and subtraction have one thing in common, that is the condition. We have to check the condition before performing subtraction, and the condition is same as the addition. That means order of two matrices should be same, then only we can subtract matrices, otherwise we cannot subtract the matrices. Okay, so I am taking an example here directly because I have already discussed the condition with the addition. So if I am having this matrix and B I am having 3, 5, 1, 4. Okay, and what I have to do, I have to subtract A minus B. So I am having 1 minus 3. So I think you can answer 1 minus 3 is equal to minus 2. 2 minus 5 is equal to minus 3. 3 minus 1, that is 2, and 5 minus 4, that is 1. So both the conditions are same. First condition, you have to check the order of the matrix. These two matrices have the order 2 by 2. So order is same, so we can perform the subtraction. And how we perform the subtraction? By subtracting the same position elements. I am subtracting 3 from 1 because 3 is same, 3 is at same position as 1. So here I am getting my answer. That is my matrix subtraction. Quite easy and simple, just as the addition. Sorry. Only one point. Subtraction is not commutative. So A minus B is not equal to B minus A. Let's check in the same example. If I am going to subtract B from A, now I am writing B minus A. So what I have to do, I have to subtract 3 minus 1. So 3 minus 1 I am getting plus 2. 5 minus 2 I am getting 3, that is also plus 3, and 1 minus 3 I am getting minus 2, and 4 minus 5 I am getting minus 1. So this is the answer of A minus B, and this is the answer of B minus A. As you can see that these are not same, so we cannot say that matrix subtraction is also commutative. It's not. Okay, so I think we are clear about addition, we are clear about subtraction. So we can move to the next operation. And in the schooling, we have these type of operation performed, that is addition, then subtraction, then we learn how to multiply. So here also we are moving to the multiplication. How to multiply a matrix. But here there is a twist in this scenario, that we are having two type of matrix multiplication, that is scalar multiplication and matrix multiplication. At this point, I will clear scalar multiplication. We will discuss matrix multiplication in the next video because it is a wide topic and it will take some time to understand. So we are starting with the scalar multiplication. Okay, so very firstly, what is a scalar multiplication? A scalar multiplication, when we multiply a matrix with a given number. Listen carefully what I am saying. I am saying we are going to multiply a matrix with a given number only. Just like I am having a matrix A, 5, 6, 2, 3, 4, 9, 1, 2, 7, whatever it is. And I am saying what is 2A. That means I have to multiply the matrix A with 2, a single number. That's why this multiplication is called scalar multiplication because we are here multiplying the complete matrix with the number only. Okay, so this type of multiplication is called scalar multiplication. And how we can do it? Very simple. If I have to multiply this matrix with 2, so what I have to do? I have to multiply each and every element with 2. So what will be 2a in this case? Here I am multiplying 5 into 2, that is 10, 6 into 2, 12, 2 into 2, 4, 3 into 2, 6, 4 into 2, 8, 9 into 2, 18, 1 into 2, 2 into 2 and 7 into 2, that is 14. So this is the answer which I got of 2a. 2 is a random number. They can provide you any number just like 2, 5, 7, minus 3, minus 4. You can do any operation like this. Just like if I have to find what is minus 3a, what I have to do? I have to multiply the whole matrix with minus 3. So multiply the matrix with 3 and add a negative sign there. You will get the answer of minus 3a. So I think you understand what the concept of scalar multiplication is. It is clear. So we are moving to our next operation. I am just holding this to the next topic. And right now we are going to take another operation that is called matrix transpose. Okay, so matrix transpose is one of the easiest operation among all of this, because whenever you are going to perform addition or subtraction, you have to check the condition first, then you have to take care of the position of the element. Okay, so but transpose is the easiest one operation. This is denoted as A transpose. We write a capital T at the superscript of the matrix name, that is called the transpose of the matrix. And how we perform the transpose? 1, 2, 3, 4, 5, 6, 7, 8, 9. For example, this is my matrix and I have to perform the transpose operation. That means I have to find what is A transpose. Okay, so in the starting video I have already told you about the rows and column. I hope you all know about this. These are rows, these are columns. Okay, so that's why I told you that first video is very important. If you are learning matrix for the first time, then you must go through the basic concept, what is row, what is column, what is order, then only you can understand the complete chapter. Okay, so don't skip any of the video in the series. Okay, so this is my matrix and I'm going to perform transpose of the matrix. What I have to do, I have to convert rows into column and columns into row. Okay, I'm just changing the structure. So this is my first row, that is 1, 2, 3 in the horizontal form. What I'm doing, I'm making it a column. I'm like writing like this 1, 2, 3. So what I did, I just take my first row and convert it into the first column. In the same way, I put up the second row and write it like this. I put up my third row and write it like this. And this is called my A transpose, nothing else. So what you have to do, you just have to change the rows into column and the columns into rows and you will get A transpose. So what I did, I just pick up first row and write it vertically. I just pick up my second row and write it vertically, and then I got A transpose. I think this is clear, but we can take another example here. So if I am having this 1, 2, 3, 4, if this is my matrix, and we have already discussed the type of matrices in the last video, so I think you can tell me which type of matrix this is, and I am going to transpose this matrix. So what I have to do, this is a column and I have to change it into row. So this is my transpose of the matrix. I pick up the first row, convert it into first column, second row into second column, third row into third column, and in this way I got the A transpose of the above matrix. Okay, so this was the definition of the transpose, how you can find A transpose, how you can perform this operation, but this operation have some particular properties. What are the properties here? The property says this: the transpose of a transposed matrix is the same matrix which you start with. What does it mean? I have already discussed that I am having A. I'm taking an example here. Okay, so in the first step, what I'm doing, I'm just transposing the matrix. I'm getting A transpose. I have already told you how to perform the operation, so I think you all know this. So this is my A transpose, and here what I have to do, this is my A transpose that I have already mentioned here, and I have to transpose this matrix. I have to perform the transpose operation on this matrix. Just like this is my basic matrix and I have to perform transpose operation on this matrix. If I perform a transpose operation on this matrix, what will I get? I will just pick up my first row and convert it into my column. So this is what I get after transposing this matrix, and what it is just same as my first matrix. These are identical. So if I transpose a matrix twice, first transpose and then again transpose, I will get the same matrix again. So this is my first property of transpose. Okay, so these properties are quite easy. You can take an example and try to perform, and you will get the same answer on the right hand side and the left hand side. In this way you can prove these property. So what is my second property says? It says if I perform a transpose on a addition, just like I add two matrices, then I perform the transpose, and either I perform the transpose on the individual matrix and then I add those matrices, I will get the same answer. Okay, in the same way, if I say A, B transpose, then what will I get here? There is a trick. It will give me B transpose into A transpose. Okay, so here when we have what is AB here? Here it is matrix multiplication. What it is? It is matrix multiplication, which topic we have skipped and we will complete it in the next video, that is matrix multiplication. So if we multiply two matrices and then we apply the transpose, that will be equivalent to the transpose of each, individual matrices and then multiplying them, but we change the order, that is B transpose then A transpose. And let me tell you, matrix multiplication is also not commutative. That means AB is not equal to BA. We will prove this in the next video when we are going to discuss about matrix multiplication. These two multiplications are not same. So here what is the property says, that if you multiply two matrices A into B, then transpose the resultant matrix, what you get? You will get this transpose of the second matrix multiplied by the transpose of the first matrix. What you can do? You can take example of two matrices A and B, multiply them, transpose them, and you can check the answer. But right now, if you don't know how to do matrix multiplication, you can skip this property, but you can definitely try this one to prove. You can take example of two matrices, add them, transpose them, and then individual transpose, then addition, and you will get the same answer. So you can definitely try this one to prove. Okay. So these are my properties of transpose. There is one more property which you can prove right now, that is if you are having Ka transpose, that is equal to K into A transpose. What is K here and what is Ka? We have already discussed about the scalar multiplication. So K is any scalar number, A is a matrix. So Ka is my scalar multiplication, just like 2A, 5A, 7A, and then we transpose that matrix. Or I firstly transpose my matrix and then multiply it with the scalar number, I will get the same result. Okay, so these are the 4 properties of transpose. You can check them by having some example of matrices and prove that you get RHS and RHS equal. If you still can't get it or you can't prove it, you can comment in the comment section. Then I will take an example and prove these properties in my next video lecture. Okay, so here what I am going to do now. So we have already discussed various type of matrices, but there are 2 special type of matrices which I hold yesterday, because they can be cleared here very betterly. So these 2 type of matrices are called symmetric matrix and skew symmetric matrix. Now what is symmetric and what is skew symmetric? So let's just understand the definition of symmetric matrix. The definition of symmetric matrix says that if I transpose a matrix, A transpose, just I discussed with you what is A transpose, and I get the same matrix as A, then the matrix is called symmetric matrix. Okay, how it is possible? So let's take an example. Just like I'm having 1 2 3 1 2 3 2 4 5 and 2, whatever it is. So this is my matrix A. So what I have to do, I have to just transpose the matrix. Okay, so let me write it here. I'm having a matrix A, 1 2 3 2 4 5 3 5 2. So this is my matrix, and what I have to check, that what if I transpose the matrix A. So let me transpose it very firstly. I have already discussed how can we transpose. Just pick my first row and make it a column. Just interchange the rows and column and you will get your transpose. So 1 2 3 is my first row and I am making it first column. First row is done. My second row is called 2 4 5. I am making it a column. And my third row is 3 5 2. I am making it a column. So in this way I got A transpose here. But let me look at the matrices. These 2 matrices are identical, completely same. 1 2 3 2 4 5 and 3 5 2. Again I am getting 1 2 3 2 4 5 3 5 2. So these 2 matrices are identical. So there are some of example in which if we transpose a matrix and we get the same matrix again, that type of matrix is called symmetric matrix. So this is an example of symmetric matrix. This is called symmetric. I think symmetric is clear. And my next type of matrix, that is called skew symmetric. And what is the definition of skew symmetric? Just a minor change in the symmetric definition. The skew symmetric definition is called, if we transpose a matrix, you will get negative A. If we transpose a matrix, you will get a negative A. So let me check an example of this if you can get. So if I write 0 to 1 here, 0 to 1 minus 1, and then 0 minus 3, so this is 3, and then we have a 0. So if this is an example of my matrix capital A, let me just transpose this. So if I transpose this particular matrix, what will I get? I pick up my first row 0 to 1, convert it into the column, that is 0 to 1. This is my second row, minus 2, 0, minus 3. So I am converting it to this one. And this is minus 1, 3, 0. So I am writing minus 1, 3, 0. Okay, so this I got while I transpose the A, that is A transpose. Okay, so what the definition says, that A transpose must be equal to minus of A. Let me check here. So what if I multiply this complete matrix with a minus, that means minus 1. What is minus a? What will be the minus a? So I am multiplying this complete matrix with a negative sign. What will I get? 0, minus 2, minus 1, 2, because minus minus plus I have already mentioned 0 and 3, and then we get 1, then get minus 3, then 0. So this is what I get while I apply minus a, and this is what I get when I apply A transpose. So these two matrices are identical and the same, so we can say that this is an example of skew symmetric matrix. So I think you understand today's concept. We started with some basic operation, that is addition, then subtraction, then scalar multiplication, and then transpose. We also understand some of the properties of addition and transpose, and then in the last I have given you the definition of two special type of matrices, that is symmetric matrix and skew symmetric matrix.